The idea of chemical equilibrium can be easily seen also when we are comparing cars moving in two opposite directions. So the cars are flowing directly from one side to the other side. Now let's imagine what happens when you have like 10 cars here and 10 cars here and 5 cars here, and two cars have moved from this side into this side. When two cars have moved from the left side to the right side and only one car moved from the right side to the left side, the number of cars on the left side has decreased and the number of right cars on the right side has increased. Why? Because at the beginning there are here 10 and there is 5, and you move 2 from here to here, while here 1 here to here 1 only. So if we repeated this again, two cars move from here to here and one car from here to here. Again, the number of cars here on the left will decrease, and the number of cars now, instead of 5, then 6, becomes 7 cars. If we repeat this again one more time, we will see that the number of cars again, two cars moved from here, one car moved from here, so the number of cars here become 8. While I can see the number of cars on the right side here, let's imagine this is as the products are increasing. The concentration here is increasing while the concentration is decreasing. Why? Because the rate of movement of cars from the left to the right, from here, from the left to the right, is less than the rate of moving of the cars from the right to the left. Moving every time from here two cars, while here moving only one car, so the rate of speed of the forward action going from the left to the right is less than the rate of the backward action going from the right to left. This leads to accumulation of cars on the right side. So if this is reactants and these are products, I will see that after a while the concentration of the products increases while the concentration of the reactants increases, because the fast forward rate is faster than the backward rate. But what happens if the rates are equal? If the rates are equal, this is what we will see as the equilibrium. This is what we will see as the equilibrium. So let's imagine this. I have 10 cars on the left and 5 cars on the right, and every time 5 cars go from the left to the right and 5 cars from the right to the left. So if I see 10, 5 from here to here and 5 from here to here. So I started here with 10 cars and I started here with 5 cars. The number of cars from the left to the right, 5 cars are moving, and from the right to the left, 5 cars are moving. So what happens every time? Every time the number of cars on the right and the left stays constant. So take care of this word because many students make mistake here. You say constant concentration in both directions. Constant concentration. It was 10 here and here 5. It stayed 10 here and here 5. So again, let's do it one more time. 5 moved from here to here and 5 moved from here to here. So every time 5 moves from here to here and 5 moves in, so 5 in the forward direction and 5 in the backward direction. So this leads to that the concentration in both sides become constant, while when the faster the rate from left to right was faster than the right to left, the concentration changes and it increased here and decreased here. Here, because there is equal rates forward and backward, it does not change. And what we are going to call this now is called that there is an equilibrium here. There will be an equilibrium here because the number or the rate of the forward reaction is equal to the rate of the backward reaction, and the concentration becomes constant. Take care, the concentration is not equal. The concentration here, there are 10 cars and here 5 cars. Don't say that in equilibrium the concentration is equal. Say it's constant. It's always 10 here and always 5 here, since the number of cars moving from left to right and right to left is always 5 and 5. So I will say the concentration is constant. Don't say the concentration is equal. As you see, it's not necessary that it is equal.